So, hello and a very warm welcome from our side. I will just start to share the presentation. Whoop. So, hello and welcome to the webinar today about centerlining. So, the headline of today is Consistent Quality, Less Weight, the Digital Centerlining for Food and the Beverage Industry. For the beginning, I'd like to just introduce myself and then also Lorenzo. So I'm Valentin, I'm a solution consultant from Workerbase. So our role or my role is always to integrate or to roll out our solutions at the customers as well as digital centerlining. And today I have with me Lorenzo.
Hello from my side too. As Valentin mentioned, I am also a solution consultant. We have the same role, and I am here because of my food and beverage expertise to provide this help for this Centerlining webinar.
Perfect. So I will just quickly jump into the agenda. And also a little note, in case you have any questions, feel free to ask them in the chat. We will get back to those questions later on in the Q&A session, and hopefully we get all the questions answered in this 30 minutes. So for the agenda for today, we will quickly go over what is Workerbase in case you do not know, and as well over the topic of digital centerlining. Just that we have a common understanding of what is centerlining and why should we digitalize it, or what is the benefit of having a digital centerlining. Then I will hand over to Lorenzo, who will give you a deep dive into how we do centerlining at our customers, and also at the second deep dive session, what can we do with AI in the matter of centerlining, and what data insights do we get. We will end the session with a Q&A session, but we will also give you in agenda point 5 a little introduction on how a roadmap for your digital centerlining journey could look like, or what it usually looks like. That being said, jumping directly into the presentation of Workerbase. So we are a platform to digitalize all of the human work activities on your shop floor, as well as centerlining is one of these activities. We're helping companies to run better processes, reduce the waste, and improve the quality. How we do that is, first of all, we have one platform for all human activities. As I said, therefore you have the low-code app builder where you can also set up the workflow automations, and you have the user interface for the shop floor employees. And also there you have the system and the AI integration you will see later on. The purpose of Workerbase is that we have a user interface for the shop floor and this industry-specific workflows ready to use for the shop floor. And that's globally proven, as you can see on the right side, with a very low ROI and trusted by those customers already. That being said, let me just introduce with a few words the centerlining and the digital centerlining. Basically, when we talk about centerlining, what do we mean by that? So you can see in the bottom of the screen, there's a chart going up and down, and you see also the dotted lines that indicates the center line here. So that being said, a center line is a defined target value or a range in this case, where critical process parameters on your shop floor or on your machines should be within to guarantee a stable production and be efficient as possible to meet the quality standards that you need to satisfy the customers. There are good reasons for vulnerability on your shop floor because, for example, when your operators doing adjustments for changeovers or something, or the raw material, as in the food and beverage industry, is quite different every time, so you need to react to that, or the process dynamics lead you to leave the center line, or the machines get warmer or wear out during the process. So that are common reasons why you leave the center line, but the center line is commonly known as the line to produce the best outcome as possible. So why does it matter? So definitely, as I said, to keep processes as stable as possible, to prevent drifts from the best known settings, so that not only because the employees change, the quality of the product change. That's definitely why you need a center line. And you also want to be as repeatable as possible. So if you have a golden batch, so a good batch that you produce, you want to produce it as often as possible and do not have varying product quality. So the goal, as I said, is to prevent waste and rework, stabilize the output, and also to variable inputs. And you want to reduce the variation and losses. But today's reality still looks like that the operators walk from machine A to machine B. This will take from 10 minutes to 2 hours to get out to all the machines. They will note everything down in Excel or paper, and the data is somewhere stored locally on someone's computer, and it's really hard to analyze. And also, you get the information way too delayed to react to it. So the answer to that is definitely the digital centerlining. So as I said, on the left side, you see the common approach of centerlining, that you have your manual notes that you share with the colleagues, or also sometimes you do not share it or they get lost. The quality of the product, it still relies on the operator memorizing what were the best settings for the product the last time. It's super intransparent because the Excel sheets get lost, or the handwriting is not good enough to be written, and also it's super delayed. So the digital centerlining is bridging that gap. So first of all, if the machine is capable, we can also directly get the parameters into Workerbase. So you have it centrally available without running around collecting the data. We can also guide our operators to do the best settings as possible. We will see later on with Lorenzo's demo. So we don't rely on the employee memorizing what they need to do. We can also store and standardize the golden runs. So if we have good badges, or also quality or processes change, also product changes, we can also have these golden runs tracked, and we can optimize the center line, because that's also a huge topic at the center lining as it is today. And also, if we have a deviation, we can directly trigger alarms. If the machine, for example, is running too hot, we realize it right on the way. And we also have a central overview of the parameters. So I don't need to run from A to B to see the real parameters. Not only that, also in food and beverage industry, you currently, or what we see at our customers is, there are definitely more challenges, but the 4 biggest challenges, first of all, starting with the skill gaps. You see it's green highlighted. So we have another webinar that is linked to this one, so you can watch afterwards if you're interested when we send out the presentation. So it's the skill gaps, it's the rising costs of raw material and also energy. You have the product volatility and frequent changeovers. So I will just spend a brief second on how we can tackle that with digital centerlining, or how we tackle that with digital centerlining. So first of all, with the skill gap, we can give best practice guidance for the employees, how to set up the perfect centerline, or how to set up the machines to get the best output. To have a consistent setup across all the shifts and not only in one. The rising costs can be tackled with faster reaction times that produce less scrap and lead to a more stable production. So we can produce less waste here. The product volatility, for sure, if we have real-time monitoring, we can see what quality the raw material is, and we know if we are in a center line or not, so we can directly react to product quality if the product quality is decreasing. And for the frequent changeovers, we can enable quicker restarts with digital centerlining. So if we need to restart the production line, with the best practice sharing and with the digital work instructions, we can help the employees to set up the machines way faster, because all the information is ready to read and available where they need it. That being said, enough of this theory. I will hand over to Lorenzo, that he can show you how we do that at our current customers.
Thank you, Valentin, for the great explanation. I will now share my screen, and we can jump into the demonstration. So let's start with a deep dive on the demo of how we do parameter collections with digital checklists. First of all, let's look at how this setup would work. This is how we have implemented it at several customers in a way that is obviously made smaller and more interactive so everyone can understand it now. We obviously don't have an own shop floor right now in our, or we don't have an own shop floor at Workerbase, but we have set up an example of this use case with a demonstration machine being just an espresso machine. So how this demo works, or this use case works, is that we have two people. On the left-hand side, we have Lisa Engelhardt, who is our shop floor worker, who will be filling out this digital checklist. She has the information available from the machine, what the parameters are on the machine right now. She has the information available, what the centerline informations are for certain parameters. And then she will fill out this checklist. And if she has to leave the center line for any reason, she will need to give a deviation reason. If we leave the center line, we automatically send an information, a message over to the team leader so that the team leader is aware at any point when the center line is left with the information of why the center line was left. With all of this, obviously, as Valentin already mentioned before, what we also do is every time this checklist is being saved, we will store this data so that we can use it in the long term for auditing and long-term optimization. On top of that, we will provide this data on dashboards so that the team leader has it available at any given time. So let's jump over and look at how it would look like on our software. So in front of you right now, you can see two screens. The left-hand side screen is the client for Lisa. So this is what this will be the client for Lisa Engelhardt, and on the right-hand side, we have the client for the team leader. Just as an information right now, you can see these two devices, or these simulations of two devices on the web service. We will, our software is able to work on any device. So it can be on the web, it can be on any kind of smartphone, or it can be on a smartwatch. So what I'm going to do now is on the left-hand side, trigger the checklist manually. But obviously, if we do, when we implement this use case at customers, we trigger this checklist from certain information we get from different systems. For example, the most use case we use is when we get the information from an MES system that we're changing the product and we need to set the values again. We automatically give the shop floor user the information. They need to fill out the centerline information or the centerline checklist to make sure that we're using the values in the center line. After the person on the left, so Lisa gets the task to fill out the center line, she can accept it and is now within the digital checklist. Why is this checklist digital? It is digital for two reasons. Obviously, first reason, we are not on pen and paper, so we can work on a device, may it be, like I already mentioned, a tablet or a smartphone. And secondly, we have live information available. As you can see in front of you, we have the information that this checklist is being saved for the machine espresso machine. We have the live information that this machine is currently running. And we have the live information from the machine that what the brew temperature is at the moment and what the brew pressure is at the moment. So Lisa on her device is seeing right now what the values are for brew temperature and brew pressure, and also can directly see that she is within the center line for both of these. We ask her to give us the information if these values are correct, as she is at the machine filling out the centerline checklist. Obviously, being live values, they will most certainly always be correct, but for auditing reasons, we always need to ask the user for to accept this or to confirm this. If for some reason it is not correct, she can press no and input the actual values. But like I mentioned, it will always be yes. So she can press yes on the machine and confirm that these are the correct values. If we now go further down, we now have the two settings that on this simulation machine need to be inputted manually. These are two settings that the machine cannot set on its own. Lisa will need to input them. Now she gets this information from us, so through the digital checklist, like Valentin already mentioned, what the center line is, what the values should be, and what they usually are. So for the grind setting, the first input, we can see the center line is between 2 and 3. And for the shot time, we can see the center line is between 25 and 30 seconds. Like Valentin mentioned, this is information that we provide the user, and the user does not need to rely on own expertise to be able to set the machine to be inside the center line, because we know the center line is a golden run we've had in the past, for example. She can now go to the machine and set the information. And if she stays within the center line, the checklist automatically accepts it and says, all values are within the center line. Perfect, let's finish the task. We can now press finish, and this checklist would be submitted, and all the information would be saved into databases and visible in dashboards for the team leader. Before I do that, let's go through it. If we leave the center line, what happens? So for whatever reason, the user decides, so Lisa decides that she wants to leave the center line for the grind settings and goes all the way up to 7, for example. We automatically ask her for a reason. She needs to give a reason why she's leaving the center line, and she can choose from a list. She has 3 options from the list, or can specify an own extra option in case it is not available in the list. In this case, let's just go with wrong bean type used. So we're using the wrong bean type. She decides she needs to leave the center line because of this and go all the way up to 7, and confirms this. So presses finish. With this, she submits the checklist, and this information is saved. And as you can see on your screens right now, directly in real time, the team leader on the right-hand side gets the message, the user has set the grind setting to 7. The reason is wrong bean type used. Now the team leader can decide how he wants to react to this information. For example, the team leader can go to the machine and set the grind setting himself, interact with Lisa, or can just accept it and say, good, if this is a valid reason, it's fine, let's leave it at 7. So with this, we have seen exactly the first part of this first product demo. We have seen Lisa getting the digital checklist because something has happened before. So we have triggered the workflow. We have her having the centerline information available to her in live. Her having put in a deviation reason because she left the centerline for a reason, and this information being sent to John directly in real time. So the team leader is already always aware of centerline, of values that left the centerline. On top of that, we use this data and save it into databases and provide it as dashboards. On the next screen, we have an example dashboard for this case. This is just a screenshot of dashboards that we can do. These can be optimized to whatever the user or the team leader wants to see in their case. Let's go from left to right. So on the left-hand side, we can see that through this dashboards, we can always provide the live data insights to the team leader. Let's say the team leader gets an information that something is wrong on a certain machine. Before even going to the machine or having to walk over to the machine or check at the machine itself what values are, they can, with their device, enter these dashboards and see directly what the live data is right now. So they can react accordingly. Maybe knowing that the brew temperature is too high, they know they have to inform a certain person, and this way we can just react faster. On top of that, we can do trend analysis. In the middle, we see a flow of the center line, which are the 2 pink lines, and how the values have been changing over the last X times we have set the center line, or we have set up the machine. In this case, it is the brew temperature. So we are seeing that the brew temperature is usually within the center line, but has had little spikes outside of the center line, but always upwards. So in this case, we can now analyze this information and maybe decide that we need to adapt the center line because maybe the machine is getting older, the performance isn't as expected anymore. So over the years, we need to adapt the center line and gradually go upwards, because for the same product quality at the end, because the machine is losing performance, we need to increase the temperature, for example. So we can analyze this information and have it available over a long period of time to constantly adapt and improve our product. On the right-hand side, we then also have the continuous improvements. We can here see the example of if the user has said that something has happened. So, for example, that it is too bitter, or the espresso is tasted burnt. We can see what resolution made the product perfect again. So we can see, for example, that in 33.3% of the times, a grinder calibration drift fixed the machine or the product being too sour or too watery. So we can continuously improve, adapt centerlining, or even know when we need to adapt something at the machine. So with this, we can provide the dashboards to the team leader at any given point, and we will continuously learn from this information. After this first demonstration, I would now like to go over to the second part, or the second demonstration that Valentin already teased. How can we include AI to help the user work through product quality issues in real time, without needing to call up, for example, a quality engineer? I will jump over to the demo screens again, and this time we will focus only on the screen of Lisa. Here we have an app that is the espresso quality check. With this, the user has the chance to input information. So how does this work? If we go to the next slide, we will see exactly what I mean with this. Lisa has the chance, as I just already showed, to give user input, and we use a data agent on the right-hand side with a chat interface to improve the process. What information does this data advisor agent use? It uses information from the latest checklists we uploaded, so it has all the Centerline information. It uses information from documents, for example, machine documentation from the machine producer, guidelines and stored documents in general, and it uses the live machine data that is available at that certain moment. With this, we have a collaboration. We have a real-time guidance to Lisa with the operator, like I already mentioned, entering feedback and the AI giving adjustment suggestions. The knowledge is available to the worker on demand. The worker does not have to inform a quality engineer. The worker does not have to go through a ton of paperwork to find these stored documents or guidelines, where often a shop floor user doesn't even know where certain guidelines or documents are stored within the many systems available. And because of this, we have faster decision times. So there's no waiting for experts. The problems will be solved directly by the shop floor user with the help of the AI. Let's test this out and do it once on the demonstration side. The user presses the app and gets the first question: what is the quality issue? As we are still in the use case of the espresso machine, let's just input the espresso is too sour. With this, the AI takes this information and collects information from the background, from the systems I already mentioned, and gives me immediate corrective actions. It gives me, in this case, 3 actions I could take to make it taste less sour. And the first one is adjust the grind settings. We can adjust the grind settings, we can adjust the shot times, or we can, and then we should retest. Another additional steps, if the problem still persists, are that we need to increase the brew temperature and obviously note all of these changes in the documents in the background. With this, we have given the user, Lisa, the chance to do a real-time guidance and take decisions faster for when the product does not have the desired quality. With this, the first and biggest issue we tackle is we have less waste. We don't carry on producing and need to wait for a quality engineer to arrive or for Lisa to find the documentation. She can directly make the decision: the quality is not what I want. How do I fix it and make the improvements? With this, we have finished both demonstrations. And now you might be wondering, well, how do we do a roadmap to digital centralizing with you, with our next customer? We do this in 3 steps. So first of all, we build the foundation. And step number one, we need to map critical processes and critical parameters. We need to automate everything that you can. So the more information we get from machines directly, the better. Obviously, we can always ask for user input too, but automation always makes the information better. And then we need to do a replace of the paper checklists with digital checklists, and obviously tag the golden runs. We need to set up the center line. In the second stage, we would then use dynamic parametered recommendations to improve the quality. So we are adding control and guidance. We can give, like for example, in the AI case, real-time operator guidance on their devices, on their smartphones. We can alert for deviations, and we provide the supervisor with dashboards. After we have set this up, stage 3 is just continuously optimizing and scaling. The more information we get through these digital checklists, the more we will learn. So we will continuously learn from every run. We can then do with the dashboards data-driven improvements and root cause analysis. And then finally, we can roll out across a lot of lines and plants with a consistent standardized logic. So it is an easy standardized rollout across a big number of lines. Let's focus on the human impact for a second. So what is the human impact for the different people if we use digital centerlining? For the operator, the shop floor user, we have the human impact that they get real-time guidance. They reduce the stress because they don't need to wait for input from other people. They can work and solve issues on their own, and therefore have the no blame culture. On the right-hand side, so on the engineering side, engineering and QA, they will have reliable and structured data instead of handwritten notes. So they will always have available the data of every single checklist that was submitted. They know when they left the center line, they know reasons for leaving the center lines, and can work on continuously improving the quality of the product by adapting certain parameters. And finally, for the supervisor, in this case of our use case, it was the team leader, we will provide him with live dashboards. Therefore, he will have faster reaction because he also gets direct notifications when a center line is left. And there is less time wasted in general chasing data. The user does not have to run, or the team leader does not have to run from machine to machine or looking for paper checklists to see what the data was the last run. Everything is available to him in his on his device. With this, we have now finished the part of this presentation and would continue with the Q&A. As we can see in front of us, there are a few questions. First of all, the first question, how do you ensure adoption on the shop floor, especially with skill gaps and resistance to change? Well, this is actually a very good question. We always develop very close to the shop floor, and we always involve the operator right from the beginning. This way, the solutions are immediately useful and easy to understand. And from our experience, when people are part of the process and and we use the feedback and implement their feedback, resistance isn't an issue. On the contrary, adoption is actually very high. I also have a second question here in front of me. I would pass this on to my colleague Valentin, maybe. So, what makes our platform in this case different from traditional MES or SPC tools for managing parameters?
Yes, also a very good question. I would go from right to left, so starting with the SPC. So when we have when you already have systems in place to track your data, what differentiates us here definitely is, first of all, the integration, that we can directly also integrate the machines, and we also help you to integrate the machines in case you don't have the capability on your side, and the machines for sure need to do that. And that's the second benefit, also related to the MES system, the direct communication path. So that means, how do you escalate with your current systems? So Workerbase gives you here the opportunity, as we saw in the demonstration of Lorenzo, to trigger following actions. In the case of the demonstration, it was just a message, but it could be also a task to change something, or a material request. So it just opens up a huge field of what we can do with it to automate the shop floor even further. So that's also the answer for the MES system. So we give a unified interface for the shop floor where you can operate as it's best or as the shop floor employees know. And I also would take the third question because this is also a bit related to the back end or to the platform then, and we are also close in time. So how can I set up the checklist in Workerbase myself? Very good question. We will have as information, we will have a follow-up webinar on that to give you a deep dive on not only how to set up a checklist in Workerbase, also how to set up a workflow inside of Workerbase. But just when you memorize how checklists look like that Lorenzo showed you, it's a you see what you get approach inside of the Workerbase platform. So it's even easier than in Word because you can just have boxes and move the boxes around and very easily configure flows there as well. Like you saw in the demo when Lorenzo clicked on no, that the parameters are not matching, then you have conditional fields opening up. And so you can have even advanced logic on that with a unified data in the back. So you can also forward this data then. So maybe not the perfect answer on how to set it up, but the answer will follow in this second webinar. So as we're at the end of time, Lorenzo, I don't know if you have something to add.
Nope, from my side, it would be with this. Thank you very much, everyone, for joining. If you have any questions regarding the Centerline, please feel free to contact us. We will be sending out these PowerPoint presentations to all the people that were in this webinar, so you can look at it in more detail on your own time. And if you want to improve your shop floor experience with digital Centerlinings, don't hesitate to contact us. Thank you very much.
Also, thank you from my side.